What secrets hide within the Chinese space station Tiangong? Orbiting silently above us at 17,000 miles per hour, this technological marvel is not just a scientific laboratory. It represents something far more complex, something that challenges our understanding of space exploration in the 21st century. Behind its gleaming solar panels and pressurized modules lie experiments and technologies that China refuses to reveal to the international community. Today, we venture inside Tiangong and attempt to uncover what lies behind the locked doors of space, in a place where science meets secrecy and where the future of humanity's presence in orbit may be taking shape in ways we can barely imagine. Tiangong. The name translates to Heavenly Palace, an ambitious title for an ambitious project. Launched initially in 2011 as a modest prototype, China's first space laboratory was merely the opening chapter in a story that would span more than a decade. What began as experimental modules has evolved into a fully operational orbital station, a symbol of China's emergence as a genuine spacefaring superpower. Today, Tiangong stands as the only permanently inhabited space station other than the International Space Station, representing not just technological achievement, but a fundamental shift in the geopolitical landscape of space exploration. The current configuration of Tiangong represents years of careful planning, multiple launches, and precise orbital assembly. Each component was lifted into orbit separately, then methodically connected in the vacuum of space through a series of complex docking procedures. The result is a structure that combines living quarters, research facilities, and life support systems into a self-contained world floating 240 miles above Earth's surface. But beyond the technical specifications and the official press releases lies a deeper question that space analysts and international observers continue to ask. What exactly is happening inside Tiangong that the world is not being told? The architecture of secrets. To understand Tiangong's secrets, we must first understand its structure. The station consists of 3 primary modules, each serving distinct but interconnected purposes. Tianhe, which translates to Harmony of the Heavens, serves as the core module. This is where the command and control systems reside, where astronauts sleep, eat, and maintain the station's vital systems. It contains the docking ports that allow cargo vessels and crew capsules to attach, forming the literal and figurative heart of the entire complex. Wentian and Mengtian, the 2 laboratory modules, extend from Tianhe like wings. Wentian, meaning Quest for the Heavens, focuses on biological and biotechnological research. Within its pressurized interior, scientists conduct experiments that exploit the unique conditions of microgravity to study everything from protein crystallization to plant growth patterns that would be impossible to observe on Earth. Mengtian, or Dreaming of the Heavens, concentrates on microgravity physics, materials science, and fluid dynamics. Together, these modules create an environment where the fundamental laws of nature can be observed without the constant interference of Earth's gravity. But beyond the official descriptions, scratch the surface, China conducts research here that spans multiple scientific disciplines, developing new medications that could revolutionize treatment of diseases, engineering crops that might one day feed millions, and testing technologies that could enable permanent settlements on the Moon or Mars. Yet for every experiment that appears in scientific journals or government press releases, analysts believe there are others that remain completely classified. Hidden laboratories, restricted experiment chambers, and equipment whose true purpose is never publicly discussed. The question that haunts space policy experts is straightforward, yet impossible to answer with certainty. What percentage of Tiangong's research capacity is devoted to projects that will never see the light of public scrutiny? The dual-use nature of space technology makes this question particularly significant. Equipment designed to study atmospheric conditions could also monitor other nations' satellite communications. Robotics developed for assembling structures in space could be adapted for military applications. Advanced materials tested in microgravity might have defense applications that would never be acknowledged in official documentation. the line between civilian scientific research and strategic military development becomes increasingly blurred when conducted in the isolated environment of an orbital laboratory. Overlay graphics showing detailed module functions, cross-sections of the station interior, and experiment chambers with glowing equipment. Technology beyond the horizon. Much about Tiangong's technological capabilities remains deliberately classified, released only in carefully controlled statements that reveal little of substance. However, analysts piecing together information from various sources have identified several areas where China appears to be making advances, some of which may represent breakthroughs that could reshape entire industries. Advanced robotics represents one of the most visible yet least understood aspects of Tiangong's capabilities. The station features robotic arms and manipulation systems that extend far beyond what previous Chinese space technology demonstrated. These systems can perform delicate assembly operations, manipulate experimental equipment with precision measured in micrometers, and potentially conduct repairs to the station's exterior without requiring astronauts to perform dangerous spacewalks. But the sophistication suggested by brief footage released by Chinese state media hints at capabilities that may exceed what any other nation has deployed in orbit. The algorithms controlling these systems, the sensors guiding their movements, and the purposes to which they might be applied remain subjects of intense speculation among space technology experts. Microgravity research at Tiangong appears focused on applications with immediate commercial and strategic value. Agricultural experiments aim to develop crop varieties with enhanced yields, improved nutritional profiles, or greater resistance to environmental stress. Medical research explores protein structures and drug interactions that are impossible to study properly under Earth's gravity, potentially leading to treatments for conditions ranging from muscular dystrophy to certain forms of cancer. Materials science experiments investigate alloys, composites, and manufacturing processes that could produce substances with properties unattainable through terrestrial production methods. Yet behind this legitimate scientific research, there exists another layer that international observers find deeply concerning. Defense-linked technology development at Tiangong likely includes sensors and detection systems whose capabilities are never discussed in official statements. Advanced computer chips and processing systems that exploit the unique thermal environment of space. Communication technologies that might provide advantages in satellite operations or electronic warfare. Experiments in areas where the boundary between scientific inquiry and military application essentially ceases to exist. The station's power generation systems, life support mechanisms, and thermal management technologies all represent advances that have broader implications. China's ability to maintain a crew in orbit for months at a time demonstrates mastery of systems that would be essential for any long-duration space mission, whether to establish a lunar base or conduct deep space exploration. Each technological breakthrough achieved at Tiangong adds another piece to China's expanding capabilities in space, capabilities whose ultimate applications may not become clear for years or even decades. Shows cinematic animations, robotic arms performing intricate assembly operations, close-ups of glowing experiment chambers, microscopic views of crystal formation, thermal imaging of station systems.
Inside Tiangong's pressurized modules, life unfolds according to rhythms dictated by necessity, discipline, and the unforgiving environment of space. The astronauts who crew the station are not merely scientists, but test subjects in an ongoing experiment in human endurance and adaptation. Their experiences provide insights into what future space travelers will face, yet much of what they endure remains deliberately unreported, adding another layer to the station's carefully maintained mystique. Daily routines aboard Tiangong follow strict schedules designed to maintain both physical health and psychological well-being. Astronauts dedicate hours each day to exercise, fighting against the muscle atrophy and bone density loss that accompany extended periods in microgravity. They conduct experiments according to precise protocols, maintain station systems, communicate with ground control, and document their activities through reports and video footage. Meals consist of specially prepared foods that balance nutritional requirements with the practical constraints of eating in an environment where liquids form floating spheres and crumbs become projectiles. Water, air, and temperature control systems operate continuously, recycling every possible resource to minimize the need for resupply missions from Earth. The station's life support systems represent marvels of engineering, extracting drinkable water from humidity in the air, scrubbing carbon dioxide from the breathing atmosphere, and maintaining temperature within narrow tolerances despite the extreme conditions just beyond the station's walls, where sunlit surfaces can reach temperatures exceeding 150 degrees Celsius, while shadowed areas plunge to -100. Perhaps most intriguing and least understood is the psychological dimension of life aboard Tiangong. Astronauts spend months in an isolated environment, roughly equivalent to living inside a small house with 2 or 3 other people, knowing that outside lies the vacuum of space and that any serious malfunction could prove fatal. The psychological testing, stress management protocols, and team dynamics studies conducted at Tiangong provide data that China considers strategically valuable. How do individuals from collectivist cultural backgrounds respond to isolation differently than those from individualist societies? What communication patterns emerge in small groups under extreme stress? How do crew members maintain motivation and performance over missions lasting 6 months or longer? The selection and training of Chinese astronauts, known as taikonauts, involves rigorous screening that extends beyond physical fitness and technical competence. Psychological resilience, political reliability, and the ability to function effectively in isolation all factor into decisions about who will crew Tiangong. The experiences of these individuals, their private observations, and the lessons learned from their time in orbit remain largely shielded from international scrutiny, shared only within China's space program and related government agencies. Visuals show astronauts floating through modules, exercising on specialized equipment, preparing meals in microgravity, performing maintenance, sleeping in compact quarters, conducting video calls with Earth. The existence of Tiangong has profound implications that extend far beyond scientific research or national prestige. Space agencies worldwide, particularly NASA and the European Space Agency, monitor it closely through various means. Satellites track its orbital path, ground-based telescopes observe its configuration, and intelligence analysts parse every piece of information released by Chinese authorities, searching for insights into capabilities and intentions. While China presents Tiangong as a purely civilian scientific facility dedicated to peaceful research, the reality appears considerably more complex. The dual-use nature of virtually all space technology means that systems developed for scientific purposes can often be adapted to serve strategic objectives. Advanced surveillance and sensor technologies tested aboard Tiangong could enhance China's ability to monitor activities in orbit, track objects in space, or observe conditions on Earth's surface. Communication systems developed for station operations might provide advantages in satellite management or electronic intelligence gathering. The international space community finds itself in an increasingly complicated situation. On one hand, space exploration has traditionally been viewed as an arena for international cooperation, where nations set aside terrestrial conflicts to work toward common goals of scientific advancement and human expansion beyond Earth. The International Space Station exemplifies this ideal, with the United States, Russia, Europe, Japan, and Canada maintaining a continuous human presence in orbit for more than 20 years through collaborative effort. On the other hand, China's development of Tiangong as an independent facility reflects both the country's exclusion from the International Space Station, largely due to American legislation prohibiting NASA cooperation with China, and its determination to establish itself as a space power operating on its own terms. This parallel development creates a situation where 2 separate orbital outposts circle Earth, each representing different approaches to space exploration, different political systems, and different visions for humanity's future in space. The limited transparency surrounding Tiangong's operations generates suspicion and speculation that might be alleviated through greater openness. However, China maintains strict control over information, releasing only carefully curated details while keeping substantial aspects of the station's activities classified. This approach, while understandable from a national security perspective, contributes to an atmosphere of uncertainty that complicates international relations in space. Visuals show satellite tracking displays, radar overlays showing orbital paths, news footage from multiple nations, animated maps depicting space surveillance networks, diplomatic meetings, space policy conferences. Looking toward the horizon, China's plans for Tiangong extend well beyond its current configuration. By 2030, officials have indicated intentions to expand the station with additional modules, enhanced capabilities, and new experimental facilities. The mysteries surrounding Tiangong are far from resolved. If anything, they seem likely to deepen as China's ambitions in space continue to grow and evolve. Future additions might include specialized laboratories for advanced manufacturing, facilities for testing technologies needed for lunar missions, or systems for supporting deeper space exploration. China has announced plans to establish a permanent presence on the moon's surface, and Tiangong likely serves as a testing ground for many of the systems that would make such an outpost possible. Life support technologies, closed-loop environmental systems, long-duration habitation modules, and psychological support protocols all require validation in the space environment before being deployed to more distant locations. The greatest secret of all may not be any specific technology or experiment, but rather the totality of China's long-term vision for space. What role does Tiangong play in plans that may extend decades into the future? How does the station fit into broader strategies for space resource utilization, planetary exploration, or the establishment of human settlements beyond Earth? The answers to these questions remain deliberately obscure, known only to select officials and planners within China's space program and related government agencies. As Tiangong continues its endless orbit, traveling more than 400,000 miles each day while circling Earth roughly 16 times, it represents both an achievement and an enigma. The station demonstrates China's technological capabilities while simultaneously raising questions about intentions, transparency, and the future of international cooperation in space. Each orbit carries the station over different parts of Earth's surface, from oceans to continents, from cities to wilderness, a silent witness to human activity below, while conducting research whose full scope and purpose remain known only to those inside. Tiangong is ultimately a story written at the intersection of science, secrecy, and ambition. It challenges our understanding of space exploration, raises questions about the balance between national interests and international cooperation, and demonstrates the technological capabilities that humans can achieve when determined to push beyond terrestrial boundaries. The station represents years of effort, billions in investment, and the dedication of thousands of engineers, scientists, and support personnel working toward goals that may not become fully apparent for many years to come. What other secrets might be hidden within the heavenly palace? What discoveries await in those pressurized modules floating above our atmosphere? What technologies are being developed that might reshape our relationship with space, with Earth, or with each other? The only certainty is that answers exist, floating silently above us, beyond the reach of those who ask the questions. The mysteries of Tiangong will continue to orbit, waiting for time and circumstance to reveal what remains hidden today. For now, we can only watch, wonder, and imagine what lies behind those sealed hatches and classified experiment chambers, where the future is being written in the language of science and secrecy, 400 kilometers above our heads.